This is the story of the life and death of a black hole. It all starts with a star. Stars are bright, burning masses of gas and energy that are mainly composed of hydrogen. The energy burned off by the star, in the form of radiation, keeps a delicate balance with the gravity of the star. When stars have a greater mass and more complex composition, iron is formed in the core and builds up until it becomes so heavy that the balance between radiation and gravity is broken, and the mass of the star implodes, feeding more mass into the core. When that happens, the star dies, and it creates a supernova explosion. That will either become a neutron star, or if its mass is large enough, a young black hole. What we know about black holes is very limited. What we can actually see is even less. Since a black hole can't actually be seen, what we do look at is a black sphere reflecting nothing, and what's called the event horizon. When something draws nearer to the black hole, time slows until it's almost frozen, and the object becomes more redshifted as time elapses until it eventually disappears towards the singularity. In order to get out of the black hole and cross the event horizon, the object traveling would need to be traveling faster than the speed of light, which is essentially just a nicer way of saying that once you're in, you're never getting out. Just like everything else in our known universe, anything born into existence will at some point in time die. And although black holes are extremely powerful, they can't escape this fate either. The black hole will eventually evaporate away until it will reach an energy greater than that of 1 billion nuclear explosions. In this process, virtual particles in empty space come into existence and become attracted to each other until they collide, resulting in the annihilation of both particles. But in a black hole, the two particles can be separated by the event horizon and will never collide. One particle will get sucked into the black hole, and the other will escape and become a real particle, rather than a virtual one. This process is called Hawking radiation, and as it happens, the black hole loses energy, and eventually becomes smaller and hotter until it radiates away.